So we're continuing in 9.3, the chapter review problems on page 611. We are doing numbers 63 and 64. Now, this is a word problem. I'm going to go ahead and read what the book says. Basically, in exercises 63 and 64, a campus dining hall is undergoing renovations. The four corners of the hall are to be walled off and used as storage units. Okay? So basically, we had this dining hall that used to be a rectangle. Now what they're doing is basically making closets at these four corners. All right. So what we need to do is find the perimeter of one storage unit. One storage unit is going to be one of these triangular storage units. Okay. We do have to use a couple of equations for this. One of them is the equation that we got reintroduced to back in section 9.2, the Pythagorean theorem. So I'm going to go ahead and put this right here because we will be using the Pythagorean theorem. Really simple, right? The Pythagorean theorem basically it tells us what the hypotenuse of a triangle is going to be. So you have a squared plus b squared equals c squared. This right here is a triangle. This theorem works with right triangles. Okay, so right triangles, there you have a right triangle right here. This is one side, this is another side, and this is going to be the hypotenuse. The hypotenuse is always going to be the largest side, the one that is opposite of the 90-degree angle. Okay, so you're going to use the Pythagorean theorem to be able to solve this problem. Let's find the perimeter of one storage unit. To find the perimeter of one storage unit, basically, all of these sides right here, these sides, and these sides are all going to be the same. And then the longer side, the longer leg of each of these triangles is going to be the same, which is this one right here. So the only side that we're missing is going to be the hypotenuse. All right, so we're going to go ahead and use the Pythagorean theorem, which is a squared plus b squared equals c squared, to find out what c is. All right, and now I wrote a subnote. Basically, when you manipulate this theorem, you can find c by just finding the square root of a squared plus b squared. Okay, but you just use algebra to figure that out. So a squared plus b squared equals c squared. Let's plug in what we do know. Now it doesn't matter which side we use for a or b because they're both just going to be legs of the triangle. So we're going to go ahead and put, we're going to make this one a and we'll make this one b. Okay, so a, here we have 2 square root of x, and now that has to be squared, plus b is going to be this side, which is 2 square root of 3x, and that's going to be squared, and that's going to give us c squared. It doesn't give us c, it gives us c squared, so make sure that you do that correctly. Okay, so let's find the hypotenuse. Let's find c squared. We're going to have to do some basic algebra and some combining of like terms and following our radical expressions. Our radical rules here. Okay, so when we go ahead and we distribute this square on here, right? The square value has to be distributed to the 2 and to the variable as well. So basically going to do that. 2 squared, that'll give me 2 squared, and then this here will give me square root of x squared. Now we know what that's going to give us. That square root of x squared is just going to give us x. We're assuming that it's positive, right? So here we have 4x basically, okay? Now let's go ahead and let's do this one right here. Same thing, right? Here we have 2 squared, and then here we have the square root of 3x squared, okay? And we know what that's going to be, right? Here we have 2 squared, that's going to be 4, but then here we're going to have the square root of 3x, right? Because that square root and that square are going to cancel out, okay? And all of that is still going to equal c squared, okay? So to be able to find then what c squared is, what are we going to have, what c is, what are we going to have to do? Well, first let's go ahead and let's simplify. Okay, let's simplify what we have here. Now, what I made a mistake here, and I went ahead and I wrote by accident that this is square root of 3x, okay? So that's a mistake. When we canceled out this 3x, we canceled out this square root, okay? So let's go ahead and fix that. This is not what we get. We actually get 4, and then this 3x is by itself, 4 times 3x, all right? So that gives us 12x actually, Okay, so 4x plus 12x, sorry about that, is going to give us c squared. Now, how do we get c, right? Because this right here, that has to be c. That's not going to be c squared. So how do we get c? We're going to have to take the square root. But first, let's combine like terms. So once we combine like terms here, 4x plus 12x, that gives me 16x equals c squared. To be able to get c, we have to take the square root. Okay, so we have to take the square root. And remember, we're assuming only the positive value, right? So take the square root of c squared. That will give me c. And then the square root of 16, the square root of 16x. Square root of 16x is just going to be 16x. Can we simplify that? Can we simplify square root of 16x? Yes, we can. The square root of 16 is going to be 4, right? And the square root of x, and all we're doing is using the product rule, right? We're using the product rule. Here we have 16x. We're splitting it up, right? Square root of 16 gives me 4. Square root of x is just going to give me the square root of x, okay? And that is going to equal c. Okay, so this is what we have so far. That is our c value. 4 square root of x is going to be my c value. We're not done yet, though, because we want to find the perimeter of one storage unit. So to find the perimeter of one storage unit, you'll see I wrote here very, very simply, all we have to do is add all the sides together. So let's go ahead and add all of the sides together, and we'll do that up here. So let's do it with the purple. We have one side, which is basically, here we have, and let's do it a plus b plus c, and that's going to equal the perimeter, okay? So the perimeter a, we said it was this, so that's going to be 2 square root of x plus b, we said was this, which is 2 square root of 3x plus now c, which is 4 square root of x, and that's going to equal the perimeter for us. So when we simplify that, can we combine like terms? Look at your like radicals. Do we have like radicals? They have to have the same index and the same radicand. They're all square roots, so same index, check, okay? Same radicand though. Only this one and this one have the same radicand, so those are the only two that we can combine. This one cannot be combined, so we're going to leave this one by itself. We're going to know that perimeter is 2 square root of 3x plus 2 square root of x plus 4 square root of x. Remember, we can treat this radical as if it were any variable, so let's go ahead and let's just call it u, and this one u. 2u plus 4u is going to equal 6u, right? But that's not our actual variable. It's actually the square root of x. So let's replace that. We're going to now know that the perimeter is going to be 2 square root of 3x plus 6 square root of x. Okay, and that is going to be our answer. That's the perimeter of one of these storage units. We're on number 64. I went ahead and I set it up so that we can actually go through it a little bit easier. So we're trying to find the perimeter of the new dining hall, and I went ahead and I outlined what the new dining hall would look like, okay? So it's not just a problem where we're taking the original and then we're subtracting what each one of these triangles would be, because that would be for the area, right? If we knew the whole area and we subtracted each one of these triangles, we found out the area of this and we subtracted, that would be a little, probably wouldn't be easy, but it'd be a little bit more simple. For this problem, we're going to have to do a little bit more, okay? So first of all, we have to understand that perimeter is going to be adding all of the sides. So let's go ahead and label each one of these sides, okay? So we have a side up here that's A, which is equidistant to this side right here, so equal in length, okay? And then same thing here, you have another side which is the same length on both of these sides. And then you have one more side right here, and all of these sides are going to be equal. So A, B, and C. Let's find the length of A, let's find the length of B, let's find the length of C, and let's add them all together to find the total perimeter, okay? I'm going to go ahead and work it out here. In the bottom, I'm going to move the page up a bit. Okay, so we're going to start by finding A. Let's find the length of A first. So to find the length of A, we're going to go ahead and write what we know. We know that this whole entire side, A, let's look at A all together. This whole entire side is where A is. Okay, this used to be 60, but now we cut off from A, we cut off this, and we cut off this. So we limited A to this to this. So what used to be 60 is now 60 minus this and minus that. So the way to set that up, we know what the length from here to here is. We wrote it down here. So let's go ahead and write that down. So we have 60. A is going to be 60 minus this length and this length. Since that length is the same, we know that it is this length right here, 2 square root of 3x, 60 minus 2 times 2 square root of 3x. Now, how did I get that? Basically, this is the length of this value right here, right? Since there are 2 of them, I just wrote that 2 square root of 3x, which is one of these, right, times 2. 60 minus both of these is going to be 60 minus 2 times 2 square root of 3x, okay? So let's go ahead and find that, and that's just going to find this side right here, this A up here on the top. So when we go ahead and we work that out, we can work it out so that we have 60 minus, simplify this, and that's going to be 4 square root of 3x. So A is going to equal 60 minus 4 square root of 3x. But there is one A up here, and there's another A down here. So basically, if we're going to add these together to find the perimeter, add all of the sides, if we're going to add these together, we're going to need to have 2 A's. So this whole thing right here is going to be multiplied by 2. And then that way we can knock all of the A's out right away, okay? If you label the sides whenever you're doing perimeter problems, it'll work a lot better. So go ahead and do that every single time, okay? So here, we're going to work this out. All we're going to do is distribute that 2. So it's going to become 120 minus 8 square root of 3x, okay? And that is that first part. That is that A value. Let's go ahead and work on the B. Now, this is not just one A. It is all A's. Okay, so all A's. So we knocked both of those out already. Now, let's go ahead and work on the B values. So side B used to be 32, but now it's 32 minus this and minus this. We know what one of these sides equal. It is 2 square root of x, right? You see how it's parallel? 2 square root of x. So that's going to be one of these. But since there are 2 of them, we're going to set it up the same exact way. Okay, so we're going to set the original, which is 32. That's going to be 32 minus 2 square root of x. But since there are 2 of them, we're going to multiply that by 2. Okay? And now when we simplify that, that's going to be 32 minus this distribute 4 square root of x. Okay? Now, that is one of the b's, right? But we need to find both of them. So since there are 2 of them, we're going to go ahead and multiply this value times 2. And once we do that, once we multiply that value times 2, we're going to go ahead and just distribute that 2 into both of these. So 32 times 2 is going to be 64. And then negative 4x times 2 is going to be negative 8 square root of x. Okay, sorry, negative 4 square root of x times 2 is going to be negative 8 square root of x. Okay, so once we get that, those are all the b's. All the b values. Okay, now we're just missing the c values. Now, we found that there are 2 a values, there are 2 b values, but how many c values do we have? We have 1, 2, 3, 4. Okay? How do we find the c values? We found the c value in the previous problem right here. We used the Pythagorean theorem, right, to find that this squared times plus this squared is going to equal c squared. When you take the square root, you can find that c equals 4 square root of x. So to find the c value, basically it is 4 square root of x times 1, 2, 3, 4. There are 4 of them. Okay, so 1, 2, 3, 4. Basically 4 times whatever c was, which is 4 square root of x. When we simplify that, we get 16 square root of x, and that is all the c values. Now, how do we find perimeter? You have to add all of the sides together. So let's go ahead and do that. Let's add all of the sides together. Okay? So to add all of the sides together, we're literally just going to set it up in an addition problem. Okay, so I have this one right here. That's my A, then my B's, and then right here. Let's add all of those together. Let's do it right here. We're running out of room, but it's okay. So let's go 120 minus 8 square root of 3x plus 64 minus 8 square root of x, 16 square root of x. Okay, we add that together and we can find the, we're just gonna combine like terms, combine the like radicals. Let's underline what our like radicals are. So first of all, we have the coefficients that are the same, 120 plus 64, that's one thing, right? And then we also have this negative 8 square root of x and 16 square root of x. We cannot combine this one with anything because it does not have the same radicand. Okay, it doesn't have the same base with anything else. So let's combine those two. 120 plus 64 is going to be 184. Okay, and then we're going to add that to whatever the green was, which is negative 8 square root of x plus 16 square root of x. That's just going to give me 8 square root of x. Okay? And then finally, the last part here is just to add whatever was left over, which is that negative 8 square root of 3x. Okay? So I went ahead and I simplified. This is actually the final answer. There's nothing else that you can simplify further, right? 184 plus 8 square root of x minus, you can't combine anything. So let's just rewrite it one more time to make it nice. And this right here is your final answer. That is the perimeter of the new value. By the way, all of this is in feet. I forgot to say that at the beginning, but that's it. So that's it for 9.3. This is the last type of problem that you need to know.